Hi, this is your host Sathya, and welcome to another brand new episode of TFiR Let's See or TFiR Demo. And today we have two guests from CloudCasa by Catalogic. It's Chief Operating Officer Sathya Sankaran and Software Engineer MD Islam. Sathya, MD, it's great to have you folks on the show.
Thanks, Swapnil. Always a pleasure to speak to you.
Thank you. Happy to be here.
Sathya, of course, we earlier talked when you folks made a switch to Velero. Talk a bit about how is this transition working out for not only you folks, but also your customers and the users who are leveraging it?
It's been a fantastic ride. We went to embrace open source primarily because that's really where every single user of Kubernetes is starting out, right? Everyone's journey is starting with open source technologies first. They use Velero, and over a period of time, maybe they identify certain things that doesn't just work with Velero, and they decide to go to commercial solutions, right? But everyone's journey starts with open source. Even our competitors acknowledge that in that place. But what we saw is when you really look at market adoption, you've got Velero with 99% of the market share, and everybody else fighting for that 1% that is, switching over from Velero, switching over from open source because, well, it doesn't meet all my requirements. And I can't wait for Velero to evolve to what I need in a very short time frame. So that's why we really said, hey, we want to embrace the open source and be where the customers are and the users are. And we want to give them a path to use our solution without actually having to switch away from open source because, it's almost a religious decision for a lot of people, right? You don't want to move from open source to closed source if you can avoid it. And that's not a conversation we want to be part of, and so we want to keep those guys there. So we feel very welcomed by this community. We started contributing very, very early on in this decision. We now actually answer, more than 90% of the questions that come up in the Velero Slack channel or the forums. Most of the questions are answered by our team. And again, it's because that was what is needed in this ecosystem because the maintainers were very strong developers, but they didn't have a background of support and supporting enterprise customers and so on. So we took on that role of again kind of just owning that community support in the back end. But we've also started making bug fixes and backporting important fixes that aren't there in the latest version. Or the version that is most deployed. So we've started doing that, and we're now actually working on some of the core features that are coming up to support KubeVirt or features pretty big. We're working with the Red Hat maintainers. We're working with the VMware maintainers to make sure those pieces are in place as well. So in a nutshell, we feel welcomed by the community. We feel like we're contributing to the community, and that only makes the community stronger. And we feel that for the users of Velero, we are a low friction path to enterprise features without actually having to move away from Velero. Completely running Velero and still getting the features that you as an enterprise user will be looking for.
If I'm not wrong, AWS is one of the first cloud providers that you folks integrated with. Can you talk a bit about, of course, it's a great mix there, AWS and CloudCasa, the benefits that users see of using CloudCasa with AWS?
Look, I think there are a dozen solutions out there that support Kubernetes for backups today. How do you stand out on this ecosystem, right? We're the first ones that really fully integrated with the AWS EKS service. And from day one, when we supported EKS, we did it in a way that we integrate directly with the EKS engine itself. There is so much in Kubernetes that is stored inside Kubernetes, but there are a lot of things, configurations that are stored at the envelope layer of Kubernetes cluster itself. Right? So that information is not sitting inside the cluster. It's actually sitting inside the guy that's hosting that cluster. And that, in this case, the most popular hosting provider in this case is EKS, right? So we integrate directly with EKS to collect information on your node groups, your VPCs, your security group settings, and MD will walk through some of the load balancer work that we did as well. We're collecting all of this information in order to make sure that when you bring back your environment, you're not just bringing back the cluster information that is sitting inside, but also the cluster itself, right? So that's one of the benefits that users of CloudCasa get with EKS that you don't get through any other solution that is out there in the market. Second, EKS itself is recommending Velero as the best practice for doing backups with their ecosystem. EKS is different in the sense that AKS now have AKS backups, GKE now have GKE backups, whereas AWS simply endorses Velero as the best practice option for you. And we are the only real solution out there that's fully compatible with running an upstream version of Velero. You run the latest version of Velero or the version that works best for you, and we simply support management and control of that on top of EKS, right? And the third thing an EKS customer should consider when they're working with us is, I talked about how we deliver agentless backups with EKS. I talked about how we can spin up a whole cluster with EKS. But what a lot of people don't recognize is you can actually back up an on-prem cluster or a cluster that is running in an AKS or GKE and utilize our recovery workflows to spin it up in EKS in the region of your choice and your account of your choice, right? So as a EKS user, you get agentless experience, you get open source compatibility, you get full stack recovery, and you get to use EKS as a migration platform as well. If you want to move to EKS, you can kind of go from anywhere, and we deliver that cluster and cloud mobility for those customers. And all of those is a very intentional integration into this EKS engine, because again, it's been the first one we started supporting, and it's still going strong.
Can you also talk about what does AWS offer for container backup today?
Look, AWS has something called AWS Backups. It actually supports 5 or 6 workloads, but EKS is not one of them. Kubernetes is not one of them. And in this context, EKS or AWS is different from the other cloud providers because Azure has AKS backup that just went public preview not too long ago. GKE added GKE backup. I think that went public preview or GA, I don't recall, but sometime late last year. So now the other 2 cloud providers offer a bit of backup built into their cloud provider services, whereas AWS's recommendation at this point and the best practice is to simply rely on the open source Velero to do its backups, right? So AWS doesn't offer an EKS backup per se, but they recommend Velero. And this is where our strategy of embracing Velero and offering all of the things the AWS user is used to, multi-cluster management, enterprise reporting and control from a central console. Look, if you're going to put all of your primary workloads and rely on AWS to manage that for you, why do you think people are going to just do a DIY on backups, right? If primary workloads are going to be something that you rely on AWS to do, backups are not something that you're going to DIY yourself. And there, CloudCasa becomes an option. Well, it is using the recommended Velero that AWS recommends that creates a whole bunch of reference architectures in, but it gives you that hosted experience a SaaS provider offers. And that's how we help AWS fill that gap with CloudCasa.
Can you also talk a bit about why protecting and restoring network and, of course, load balancer configurations are important in cloud, because mostly cloud is seen as a magical place?
Because you can't just take a cluster from one place and try to restore the Kubernetes cluster in another place and expect everything to magically work, right? People talk about the fact that the platform offers a lot of portability and mobility. That just tells you that the binaries will come up and run. It doesn't mean all the dependent services that it relies on are going to work by simply taking a cluster from one cloud provider and try to run it in a different cloud provider, right? And this is where how you build the envelope around your cluster is very, very important. What services are you are you dependent on your cloud provider to give you? Almost every AWS user has some level of network connectivity that is again very proprietary to what AWS offers. And there is load balancer that you often will use the default load balancer that is out there that is being offered by the service. Security groups. Almost every AWS user uses a concept of IAM accounts and enable that certain people have certain roles and access controls and so on. And all of this information needs to be captured in some way so that when you bring back a cluster, you can either map this to a different account, map this to a different region, or potentially even to a different cloud provider, right? So it is important that you bring your whole self. When you bring up a workload, you bring up the whole workload, not just the underlying binaries and the container images and the cluster configuration, but also how is that cluster, what is that cluster dependent on? Can you bring back all of that during the restore process as well? That's what we make the job easier. Otherwise, the alternative is, someone has to manually go and configure everything, make sure that these settings match the settings that were taken at the time of backup, which is great on paper. Yeah, a lot of people can do that. But oftentimes you don't even know what worked once you've lost the data, right? If you don't have a great recording system, you're not even going to know how it was previously configured if you don't record that information during backup. And so we fill all of those gaps so that you don't have to rely on a manual process to get a cluster up, and you don't have to sit and record and transform when we can do all of that for you automated and essentially deliver recovery as code.
MD, now it's your turn. Let's do the demo now.
So I've logged into my CloudCasa account here. So this is the CloudCasa dashboard. So what I'm going to be showing today is I'm going to be doing a backup of an EKS cluster along with all the associated AWS resources like the VPCs, subnets, the load balancer, as Sathya mentioned. And then I'm going to be taking that backup, and then I'm going to be doing a restore from that backup. So the first thing that you need to do is to actually register your AWS account with CloudCasa. So to do that, you would go to Configuration, Cloud Accounts, and then you click on Add Cloud Account button on the right side here, and then you can select AWS as the provider type and click Next. And then you see here you have this Launch Stack button, which will open up the CloudFormation Stack page on AWS. And here you can use our CloudCasa CloudFormation Stack template to actually register your AWS account. And then you can see here there are specific permissions, specific features that you can enable that corresponds to specific permissions on AWS, right? So like EKS, RDS, and EBS volume, stuff like that. But in my case, I've already registered this AWS account, so I can show you that here. As you can see, I have one AWS account registered in CloudCasa. And once you register your AWS account, it'll be an active state. So once you do that, you can actually click on the AWS account, and then you can see that CloudCasa has discovered all your AWS resources. And in this case, you can see that I have two EKS clusters that were discovered. So you can see here, one is in discovered state, one is in an active state. So once you register your AWS account, all of the clusters will be in discovered state. But to get it into active state, you actually need to install our CloudCasa agent. And to do that, you go to Action and Install, and then you can see here you have a kube control command that you can copy and paste to actually install our agent. So the EKS cluster that I'm going to be backing up today is this EKS cluster here, MD-test-2. So if I can show you on the AWS console, right? So over here, I have two EKS clusters, and this is the cluster that I'm going to back up here. So I'm going to copy that, and I'm going to go to my terminal here. I'm going to connect to this cluster here, AWS EKS update. Config. Right, it's the cluster here. Okay, so you can see here that in the CloudCasa IO namespace, I have the CloudCasa agent installed. And then you can see, so I have a few web applications running here in 3 different namespaces, so Web 1, Web 2, Web 3. I have some WordPress sites running, and I have, so if you look at, see the persistent volumes, right? You can see here that I have 6 volumes, and I have, so now let's look at the load balancer setup here. You can see here that I have the AWS load balancer controller running, and I have, so let's see here, right? So I have a service, this service here, which is of load balancer type. So this is my first load balancer here. Let's see if I have any more. Right, so I have an ingress running, so that's my second load balancer here. And then if I look at my target group bindings, right, so I have, you can see here, so this is the service, this is the ingress, and then this is a third load balancer that I have here, which I created manually, that I can show you on AWS. So over here, if I go to the load balancer page here, you can see that I have 3 load balancers associated with its EKS cluster. So 2 network load balancers, 1 application load balancer, and one of these load balancers, as you can see, was provisioned outside the scope of the AWS load balancer controller. So this one could have been created manually or through something like Terraform. So what I'm going to do is I want to back up everything, right? So I want to back up my EKS cluster, the configuration, the Kubernetes resources, the persistent volumes, and the load balancers, VPCs. So I want to back up all of this information, right? So to do that from CloudCasa, what you would need to do is you would go to protection, backups, and then you can define a backup here and select your cluster. So click next, and then you can, so we have options to select specific resources, but I'll leave everything as the default here. You can see here like full cluster, you can select namespaces, select resource types, labels, include persistent volumes, or this also, you can do a snapshot only, or you can do a snapshot and copy. So you can actually copy the data to CloudCasa storage, or you can specify your own storage. But I'll leave everything here as it is like that and click next. So there's hooks, pre-backup hooks, post-backup hooks. I'll leave that as it is and click next. So there's policy information here. You can back up based on a specific schedule that you provide, but I'll leave that as it is. And then here you can just set up you can just put a backup name. You can call it anything like demo1 or whatever. And then you can click create here. So I won't be doing that now because I already have a backup that I ran yesterday, so I can show you that. So if I go to protection, backups, and I click on this backup here, you can see I have a backup that ran yesterday that is completed, and you can see that all my persistent volumes were snapshotted and copied. And then if you look at the activity log, okay, so here you can actually see what was backed up. So if I scroll down here, you can see that, so it backed up all the Kubernetes resources, right? So the namespaces, the PVCs, and then you can see here it backed up the configuration of the EKS cluster, the node groups, the VPC, the subnets, the security groups, and then you can see here that it did back up that one non-controller provisioned AWS load balancer. And then if you scroll down, you can see that it also copied the data as well. So yeah, and then the ingress and service and target group bindings as well, as you can see. So that's for the backup. So once you have that backup, you can actually restore from that backup. So if I go to restores, I can click on define restore here, or I can go to recovery points and I can select the latest recovery point over here and click on restore. And just like backup, you see you can select specific resources to restore, like select namespaces or labels or resource types, but I'll leave everything as it is and click next. Okay, so here you can select the destination. So you can either restore to the existing cluster, so the MD test2 cluster, or if you have another cluster registered, you can restore to that cluster. Or in my case, I want to create a new EKS cluster. based on the configurations in the backup, right? So I click on that and then click on EKS cluster, and then you can select an AWS account, which account you want to restore to. So in my case, I only have one account, but if you have multiple accounts, you can actually restore to a different AWS account. So for here, I'll click next, and you can specify a name for the EKS cluster, so like demo1, next. The AWS user, so this is the user that will have access to this EKS cluster once it's restored. So I have that set that to my user. That you can select the region, what region you want to restore the EKS cluster to. And the other field, these are I'll leave it as it is. These fields also exist in the AWS console, so I'll leave that as it is. But all of these informations are pre-filled for you from the backup. So it's getting all this information, like this, for example, this network information is coming from the backup. So I can actually have CloudCasa create VPCs and subnets for me from the based on the configuration it got in the backup. Or I can have the option of specifying what VPC and subnets I want to use. But I'll leave this as it is and click next. Same with the node pool configuration. So all of this information comes from the backup, or you can customize it as you want. But I'll leave it as it is and click next. Okay, so this is the page that we wanted to come to. So this is the load balancer section. So here I can actually, so it's asking for the IAM role for the controller, the load balancer controller. So I can actually specify what the IAM role here is. So I can do that. Right. So this has permissions to access the load balancer on AWS. And then over here, we can actually modify certain resources, the Kubernetes resources. So for example, like the service, if I want to modify the service, right? So let's say I want to modify that WordPress service that you saw earlier, right? Let's say this WordPress service is the load balancer type, but let's say I don't want this as a load balancer, right? I don't want to expose this service. I can just set it to cluster IP and save it here. Or I can modify the ingress, for example, right? Let's say this ingress resource here, let's see. Let's say I want to change the host, right? So I can change the host here, right? I want to change the host, I can do that. And I can also, of course, I can also do target group bindings. I can update this as well. Okay, and so the last thing here is the non-controller provision load balancer. So this is the non-controller provision load balancer that I mentioned before, right? So this could be created manually or through Terraform. So this one is coming from the backup. You can choose to have CloudCasa restore this for you from the backup. So I'll leave that as it is. Click next. And these are the list of add-ons. I'll leave this as it is. So this is the role for the EBS CSI driver. I'll leave that as it is. So you have the options here. So rename namespaces, change storage classes, preserve node ports if you want to, and overwrite existing resources if there are any. Click next. Post restore hooks. I'll leave that as it is. And over here you can just set a name, right? Demo restore, right? And then you would click on restore here. So I already had a restore that I ran yesterday, so I can show you that here. So if I go to protection, restores, and I click on the restore that I had, you can see here I had a successful restore job that ran yesterday. And then over here, if you look at the PV details, you can see that all the data of my persistent volumes in the backup was copied over to my new EKS cluster. And you can see here, so what did it do in the activity log, right? You can see that it started the restore of the EKS cluster. It created the VPCs and subnets from the backup. It created the new EKS cluster in this region, the US East 1. It created the node pool, node groups, and then it gave access to my user. And then it set up the OIDC provider. It set up the service account with the EBS CSI driver. And then you can see here that you created the non-AWS load balancer controller provisioned load balancer, right? So the one that was created manually, so it created that, and then it set up the AWS load balancer controller here, as you can see, and then you can see here that it restored all the Kubernetes resources, including these services and the ingress and all that stuff. So all of that is now restored. So basically, what just happened is all of the configurations of the EKS cluster and the Kubernetes data, the Kubernetes resources, the permission volume, the subnets, security groups, uh, the VPCs, the load balancer. So all of that has been restored from the backup.
Sathya, MD, thank you so much for, of course, talking about Velero, CloudCasa, and thanks for this demo. And I would love to chat with you again. Thank you.
Awesome, Swapnil. And always a pleasure talking to you.
Thank you.